Hello everybody, today I can calculate distance slash length using d equals radical delta x squared plus delta y squared. So that is what we call the distance formula. We're going to unpack what all that means, and we're going to start by doing a question that we did earlier this year, because this is going to kind of lead into the distance formula. So to solve this problem right here, I have a right triangle, I have two sides, I want to find the third. So I do Pythagorean Theorem. A squared plus b squared equals c squared. Where a and b are the legs, which in this case are 6 and 8. C is the hypotenuse, that's x. 6 squared is 36, 8 squared is 64. To get rid of the squared, I do the square root, and I would get x equals 10. So that is an old topic. We did that in the right triangles unit at the very beginning of the right triangles unit, and that is going to link into the distance formula, because the distance formula is actually based on Pythagorean theorem. So here's what I'm going to do. I'm going to do the first example. I'm going to use the first example to show you where distance formula comes from. So what I'm about to do, don't write down, just kind of follow along, and then I'm going to erase it, and then I'm going to do it the way that I want you to do it moving forward. So I have 5, 1, and I have 2, 5. I want to find this distance. I want to find the length of that segment. Well, what I can do is I can create a right triangle. I'm trying to find this. This side is 1, 2, 3. This side is 1, 2, 3, 4. And then I can do Pythagorean theorem. I'm not going to solve it from there. I just wanted to show you where it comes from. Now, check this out. I know that Pythagorean theorem is a squared plus b squared equals c squared. Well, the leg, let's start with this leg. This leg is the change in the x values. This leg is going to be how many x boxes have changed from there. So I'm going to rewrite a as the change in x. This little triangle, that's a Greek letter. It's called delta, and it represents the change. So it means the change. It's called delta. This leg, well, this leg is the change in the y value. So I'm going to replace b with the change in y. C, well, this is the distance that I'm trying to find, so I'm going to replace it with d. Now, I don't want a formula for d squared, I want a formula for d. And that's where the distance formula comes from. So the distance formula is, so now, again, I said initially not to writing this down. Now we're going to start doing the problem for real and writing it down. 5, 1, 2, 5. I want to find the distance between 2 points. Distance equals radical delta x squared plus delta y squared. So delta x means count. So basically we're counting from one point to the other. Delta x is how much the x value changes, which in this case is 3. Delta y is 1, 2, 3, 4. 3 squared is 9. 4 squared is 16, just like Pythagorean theorem. 9 plus 16 is 25. Now, if you can take the square root of it, take the square root of it. If not, leave it. I don't want to get too crazy with that stuff. That's not my objective of this lesson, is not to reduce radicals, but we'll keep it simple. If we can take the square root, we will. My distance will be 5. So, to find the distance between 2 points, we use distance formula. D equals radical delta x squared plus delta y squared. To find delta x and delta y, those mean the change in x and the change in y. I am counting in the x direction, and I am counting in the y direction. Number 2, 9, 1, and 1, negative 5. 2, 4, 6, 9, 1, and 1, negative 5. I want the distance between these 2 points, so d equals radical delta x squared plus delta y squared. 1, 2, 3, 4, 5, 6, 7, 8. Delta x is 8, so I'm going to write 8 squared. Delta y is 1, 2, 3, 4, 5, 6. 6 squared. From here, I just solve it. 8 squared is 64. 6 squared is 36. 64 plus 36 is 100. Square root of 100 is 10. And that's my answer. I'm just substituting into the formula. D equals radical delta x squared plus delta y squared. And to find delta x and delta y, I'm counting from one point to the other on the graph. Now, another way to get delta x and delta y, I could subtract. I don't like subtracting because I find that students make tons of subtraction errors, especially when it involves negatives. But I could have done 9 minus 1 is 8, 1 minus negative 5 is 6. You can go that route, but I like to have my students count on the graph. Number 3, 2, 5, and negative 1, 8. 2, 5, negative 1, 8. D equals radical delta x squared plus delta y squared. I want you to try it from here. Count. Count from one point to the other. Count in the x direction. Count in the y direction. I'll give you about 30 seconds. One, two, three. That's delta x. 1, 2, 3. That's delta y. 3 squared is 9. 3 squared is 9. 9 plus 9 is 18. I can't take the square root of 18. I'll leave it like that. We can reduce it into our perfect squares and our non-perfect squares, which we did in the when we did those Hill-Sass problems. If you want to do that, that's great, but I don't want to confuse this. I don't want to make it any more complicated right now. My objective is for you to just substitute into the distance formula and get to the answer. That's basically it. Why don't you try let's take a quick look at number 5. Negative 4, 1, and negative 1, 1. Negative 4, 1, negative 1, 1. If it's a straight line, you don't have to use distance formula. What's the length of this line segment? 1, 2, 3. Done. So if it's just a straight line, you don't have to use distance formula. If it's a horizontal or vertical line, just count the boxes. Why don't you try number 6 on your own now from scratch? So please pause, then try number 6 on your own, and then unpause. Okay, now that you tried number 6 on your own, 10 comma negative 1, 2, 4, 6, 8, 10, negative 1, 2, 4. To find the distance of a line, or the distance between 2 points, or the length of a line segment, delta x radical delta x squared plus delta y squared. We do have a song for this, but I'm going to wait until we put all the formulas together to do the song. Delta x is 1, 2, 3, 4, 5, 6, 7, 8. Delta y is 1, 2, 3, 4, 5. 64 plus 25. 64 plus 25 is 89. You can leave your answer like that. That's your answer. Let's just flip and see what else I got here. So for something like number 10, I can't really plot these points. So I know that distance equals radical delta x squared plus delta y squared. In a situation like this, to find delta x and delta y, I mentioned it earlier, you're going to have to subtract. It doesn't matter which way you subtract because distance can't be negative. Whatever you get, you're just going to kind of make positive. So for the x's, it would be 47 minus negative 13, which is 60. And for the y's, it would be 2 minus 6, which is negative 4. Now again, since I'm squaring it, it's going to become positive. So you could just put in 4. It's really not a big deal. 16 plus 3,600. Use a calculator if you need to. And that would be rad 3,616. So listen, I want you to count. I feel like a lot of mistakes are made when there's subtraction going on. However, if the numbers are really big, which does not come up often, but if it does come up, then you'd have to subtract to find delta x and delta y. Is there anything else I want to go over with you? Maybe? I guess let's just take a quick look at number 13. The endpoints of A, B are A, negative 4, 5, and B, 2, negative 5. What is the length of AB? Well, the length of a line segment is the distance between the 2 points, so I have to use my distance formula. Distance and length are the same thing. Why don't you pause it, try and finish it on your own, and then unpause. Okay, now that you did it on your own, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 6 squared plus 10 squared. 36 plus 100. Radical 136. Do I see that there? No. I mean, it's not 2. It's not 8. It's not radical 61. Choice 1 is it has the radical reduced. And if I reduce this radical, that's where the 2 rad 34 would come from. But again, for the majority of these, I don't really want you to worry about that. But for this one, you would have to do that. And if you have big numbers, like in number 15, you'd have to deal with that as well. And if you're not comfortable reducing radicals, there's a video on that. It's the Algebra 1 skills when we're doing the similar triangles chapter. So to calculate distance, d equals radical delta x squared plus delta y squared. Delta x means the change in x. Delta y means the change in y. To find the change in x and the change in y, I want you counting on the graph. However, another option is to subtract the x values for the change in x and subtract the y values for the change in y. Your classwork/homework is to finish calculating distance and length, and I hope everyone has a great day.